Hi, I'm Philip from the HANA Academy. In this series of videos, we're looking at the graph processing capabilities native to SAP HANA. In this video, we're going to look at a significant new capability for pattern matching that's been added with HANA 2.0 SPS 0. Now, up to now, and we've seen in previous videos how you can do pattern matching using the graphical pattern editor as part of the HANA Graph Viewer. However, it may be preferable you want to use some kind of scripting to do your pattern rather than to use this graphical editor. And that's now possible. What you can do is use the Cypher query language. So basically, HANA Graph now supports a subset of the open Cypher query language. Now, it's a kind of SQL-like language, but it's not SQL. It's specifically for working with graph structures. And so we'll have a look at that in a moment. If you want to know more about Cypher query language, then a good thing you might want to do is select that and actually put that into Google or your favorite search on the web, and you'll get lots of information. This is not something that SAP created. It's actually originated by Neo4j, who have a leading graph database. And if you go to some of the sites that you'll find, you'll get a good introduction into what the Cypher scripting language is. This is very good in terms of if you already know something like Cypher, you've worked with other graph databases, or you've got apps that have been written in other graph databases, you can transfer that knowledge and even easily migrate those apps into HANA when your data's in HANA, because you'll be able to use the same kind of Cypher scripting language. Now, Cypher is a declarative language. It's inspired by SQL. You can get some good overviews on how it all works here. But it's really very simple. Rather than drawing a pattern in terms of a picture where we have different vertex and effectively nodes and then edges that we use to connect different nodes together, you basically use ASCII-like syntax to represent that. So you can see here that we've got, for example, two vertices A and B, and they've got braces, they've got round brackets around them, and that's basically trying to show that these are then going to be vertices. And we also have relationships. So we can, for example, A likes B. Now, if we look, we can see we've got a dash and then another dash and an arrow pointing in the direction of one vertex to another. So this is how we represent the relationships or the edges. And of course, then within these brackets, and we've got square brackets, in fact, for when we're dealing with relationships, what we put inside those allows us to be more specific about which node it is, etc., and reference properties, etc. So that's really the key. Now, where are we going to specify that? Well, we do that in a statement which is called the match statement. So you can see here there are some examples. We've got match, and then we reference a specific node or vertex in braces, in curly brackets. Then in this case, just two dashes and an arrow to basically give us a connection, and then our second node again in curly brackets. So when we're going to work with the Cypher language, we're almost always going to have a match statement, which is where we kind of draw the pattern of what it is we're trying to match when we're getting data out of our graph database. Of course, we want to specify typically some kind of filtering. That's where we're going to use a where clause on the different properties that we've got. And also you'll need to say which properties do you want returned. It's a bit similar to the list of columns you would put in a select statement in SQL. So there's also the return statement where you specify your properties. You can also have order by and all sorts of other kinds of statements as well. But the match, where, and return are the three key ones that you're likely to want to use. Now, of course, that's all been well documented. So if you go to the HANA Graph reference, we've seen already where you can get that, help.sap.com/HANA. You'll find in the algorithm section for pattern matching, we've got a section on the Cypher query language, and it gives some quite good examples of the subset of the Cypher language that's supported within HANA. Now, when you're going to work with Cypher language, you don't just sort of put it in directly and submit it. What you need to do is basically have it wrap wrapped inside a calc scenario or calc view with a calc scenario. So you can see here we've got a calculation scenario, and then we've got actually some code here. It's this code here which is our Cypher script, and then the rest is just the sort of the wrapping to actually make it fit again within a calc scenario of HANA, because that's where we work when we're working with the graph database in terms of data access. So let's go back to our web browser. We've actually got the catalog window open, so we'll be able to actually run some SQL. So maybe I'll just select my schema, and now we can see that I've opened up a SQL window, and it's going to run by default against that schema with my user. Now we've got some code. It's similar to what you'll find in the reference guide. You can download it, get it easy to copy and paste by going to GitHub to the SAP HANA Academy repository, and then in the list of repositories you'll find there's the graph. And for this video, we're looking at number 15. So it's graph 15, pattern matching with Cypher. And you can see here is a nice little example. Now, the easy way to copy and paste that is put it into raw, and then you can do a Control-Alt, for example, Control-Copy, Control-C. That's a nice way to get that code. So I'm going to take that code and I'm going to paste it now into my catalog viewer. Now, don't be surprised if you get some little red lines. Sometimes it's not entirely, the way it reviews the code is not totally up to date with what you can actually do, but don't worry, this does work. We can see the code now. We've got this create calculation scenario where we give it a name, and then in single quotes we have our full XML for that calculation scenario. So we end with a single quote, and that's important because if we're going to need to use quotes, for example, for literals inside our Cypher script, then we're going to need to double quote them. We're going to need to put two single quotes, otherwise they won't be escaped properly. So we can see we've created a calculation scenario, and within that we've specified the code you would do if you want to create a calculation view, and within that we've used the graph node. So we're basically saying this is a graph processing calculation view. We've got the view attributes to specify basically what the key properties are going to be that get returned. And then the important part is this expression section. And here we can see that we've got a CData, and then we have within that tag, the CData tag, we've got our Cypher query language. And it's at this point that you can code anything you want that's supported. So in this case, we maybe got two different nodes or vertices. We've got A and B. So we're going to say match A and B. And we've also got another pair, A and C. So actually three vertices in this example. So we want to do a match where we basically say, I want to match A and B, and at the same time match A and C. And I've got an edge defined between A and B, that I'll call E1 for edge 1, and I've got an edge between A and C, I'll call E2. So I've basically defined my picture, my pattern in the match statement. And then how do I pick out what data I want to see? That's where I would code into the where statement. So we see here where A.name, so where the property called name of any vertex we have in our database is less than the b.name. Okay, that's just to avoid us getting the same rows more than once, because sometimes it can go in bidirectionally. You get what's known as a kind of symmetry or an automorphism, and you can get the same results twice because it can go both ways through your pattern. So this is just to make sure we get it just one way through the pattern. And then we filter saying e1.type is equal to married to. Now married to is the value of a property called type. We know this from the previous videos where we've seen the structure we're working with for the Greek mythology example. But notice how married to, as it's a literal, it needs to be in single quotes. That's the HANA syntax. But because it's inside this calculation scenario where we've got single quotes actually wrapping the whole lot of XML, there we need to put a double single quotes, so two single quotes together whenever we really want to use what normally would be a single quote on its own. So married to is a value, so we're basically saying from A and B we want to identify all of the patterns in our database where we've got different vertices that have the relationship of being married to each other. And then we want to say, well, from one of the ones that's married, in this case A, we want to also then filter, give me all of the ones where as well as being married, that they have a relationship with another entity which is a god and which lives in Olymp. So all the basically what are going to be parents who are married, that then basically have given birth to gods, and that those gods live in Olymp. So again, Olymp is a string literal and God is a string literal. These are things that are specific to our data. So we've done our where clause that then allows us to filter effectively what's in that pattern, that match we've specified. And finally, we've got a return clause. So in the return, we're just going to list the names, and we can change the names as we've done here. So a.name as the parent 1, b.name as parent 2 property, c.name as the child name. So we can get those three columns or properties out. So that's our return statement specifying the properties we want and the order that we want them in and what the actual name of those properties will be, which of course corresponds to what we've got in our view attributes as the three output properties. Each of these are data type string. So that's really it. Of course, you can do anything you want in here. This is just one very simple example, but let's go ahead and run it. You can see just after I've done a select star from and then the name of my calculation scenario. And in case you've already run one, you can always add a drop statement in just beforehand. Not needed in this case. As you see, that's why it's red, but it doesn't matter. We've now created our calculation scenario, and we can see we've got our results. We've got Cronus with Rhea, who had two children, Zeus and Hera, both of which live in Olymp. Demeter and Poseidon as well, and we've got Hera and Zeus, who have a child, Ares, that also lives in Olymp. All of these children are gods. So of course, again, this is just one simple example. You can basically set up any kind of pattern you want, any kind of filtering and selections you want. So you have a very, very deep control, and you're not dependent on having to install the graph viewer or work with the XS Advanced Web IDE Calc View Editor. You can do this all in script, basically using the Cypher query language. So this is something that's been added with HANA 2.0 SPS 0 for graph processing in HANA. Thanks for watching. You'll find more videos and playlists on our YouTube channel. Also consider following us on Twitter or connect with us on LinkedIn.